We are now ready to start writing equations for situations with exponential growth and decay. So the question is, write a function that represents the situation. The word function just means that we're going to write that equation. So question number 1, sales of $10,000 increase by 65% each year. If it is increasing by a percent, we can write that as an exponential equation. Remember, f of x equals a times b to the x is our exponential function, with a being the y-intercept, or our starting value, and b representing our multiple, which we will get from our percent right here. So our starting value is 10,000, so we write f of x equals 10,000 times our multiple is going to be given by the 65%. So we have to go back to our section, or part 1 of this section, and remember that 100% plus the 65% gives us a total of 165%. That will be our multiple written in decimal form. To put that in decimal form, move that decimal over twice and we get 1.65 to the x. That's question number 1. Number 2, a population of 210,000 increases by 12.5% each year. So we get f of x equals our initial amount, which is 210,000. So that would be 210,000 right there for A. Our increase is going to be 12.5%. Let's think about the 100%. Plus the additional 12.5%. That gives us 112.5% written in decimal form again. Ends up being 1.125, and we're going to be to the power of x again on that one. Now, in the homework you might see that this x is replaced by t for time or some other variable. That doesn't matter too much. Just make sure that you pay attention to which variable you're using. Let's go over here to some decay questions. I know it's decay because of words like decrease. All right, our population of 100,000 decreases by 2% each year. So we have f of x equals, again, our initial value, 100,000. That would be 100,000 written here, times, let's figure out what our multiple is. Now, our 100% is decreasing, so subtract 2%, that puts us at a total of 98%. 98% written as a decimal is 0.98 to the power of x. A stock valued at $100 decreases in value by 9.5% each year. So f of x equals our initial amount, which is $100. Our multiple, again, will be figured out by this 9.5. So we're going to do our 100% minus the 9.5% that it decreased. That gives us a total of 90.5%. Written as a decimal will be 0.905 to the power of x. Now with this, we're able to tackle the question that we ran into at the beginning of this section where we had a starting salary and wanted to figure out how much we were going to earn in 10 years. So let's take a look at that. What will your salary be in 10 years if you start at $35,000 and it increases by 4% each year? So f of x equals, we've got our starting value right here, which is 35,000. We're going to multiply that by our 100% plus the 4%, which gives us 104%, written as a decimal, will be 1.04. All right, now this function allows us to finish calculating for 10 years. That x is our variable that represents the years, so we're going to take that, we're going to replace it with 10 in both places. So let's erase this real quick. That would be f of 10 for 10 years down the road. It's 35,000 times 1.04 to the 10. Now this is a tough calculation to do by hand, so I'm going to plug that into the calculator. 35,000 times 1.04 to the 10th power, and that gives us $51,808.55. $51,808.55. And you might want to round that to the nearest dollar or whatever is appropriate for the situation. Thank you, and begin on the homework from section 6.2.